afternoon, everyone, and welcome to Cisco Live. And this session is about introduction to Application Centric Infrastructure. My name is Vulcan. I'm one of the technical leaders from Technical Services, or TAC, from Cisco. And I joined Cisco TAC from 11 years ago. Before actually I started my career around 1999. And I hold 3 CCIEs. And my current role is the technical leader and handle the escalations as well as leading the automation and other initiatives of our team. And today, I have the privilege to have a special support from many colleagues from Cisco. And one is Mr. Roberts, and he's going to help us host the quiz, and please shoot all your tough questions to him. And I have my mentor, Michael P. from Cisco, who is a technical leader as well, Michael. And my colleague, Kate, and there are a bunch of other Cisco speakers and Cisco employees. I really appreciate your presence and be part of this session. The purpose of this session is to help you build a fundamental understanding of the application-centric infrastructure so that you could have better understanding from the architecture, concept, and the terminology perspective. And at the end of the session, when you walk out of this room, I believe you will have a better understanding of these very cutting-edge technologies, and you will have a better option to resolve the business challenges today. I would like Mitch have a quick introduction as well, please.
Hey everyone, I'm here supporting Welking. Look, just a little bit about this. This is Welking's first presentation. So Welking is part of a group of exceptionally gifted TAC engineers. And this is stepping outside his comfort zone. He's talking about, I guess, the fundamentals. This is the guy when the things explode, the team takes care of this. So he's living and learning. Any feedback, any questions, keep this lively, keep it interactive. There's more than enough Cisco people in the room to sort of answer any questions, but give us some feedback along the way, okay? I'm Mitch Roberts anyway. I'm a group manager for all the ACI content here at Live. Again, we thrive on that feedback, so be honest and be constructive.
Thank you, Mitch. And all the sessions, even before the session or after the sessions, we have Cisco Spectrum available. So if you have any questions was not able to ask, then feel free to reach out to us. And my session starts with one of the very particular person called Agent Smith. Does anyone still remember who this guy is? Yeah, thank you. I heard some answers. Yes, the Matrix. And Agent Smith is actually one of the most impressive characters in the movie called The Matrix. And he has some unbelievable capabilities to replicate himself in multiple copies and deployed from anywhere, anytime, whenever which is required. Definitely he's not doing good things, but bad things. And The Matrix has very special interfaces for the people hooked in so that they could learn additional skills while loading a program. And from the source code perspective, from Neil, who is our hero, and he views that Agent Smith is not a real person, instead an application which is created by the artificial intelligence to control humans from 2050. And the Matrix movies has 3 series, and which is the most successful one from 1999 to 2003. And during the past 15 years, in the IT world, the application has been evolved dramatically. And the DevOps demands the applications to be deployed even faster, from weeks to minutes. And the cloud has endowed new attributes like dynamic instantiation and removal. And the infrastructure independent and multi-tenancy support, so that any workload can be deployed anywhere at any time whenever required. And our ecosystem partners started to utilize APIs to integrate the infrastructure's interface to their business system so that they could achieve automations and better productivities. And security is always a top priority, and nobody would like expose important information like source code. However, the legacy infrastructure we have today is actually still managed by a distributor mode, which is a very siloed approach, which requires multiple teams to be engaged, get the infrastructure ready in order to support applications. And VLAN, which is the most popular segmentation technology in the past, which only supports 4,000 unique IDs. And the extension of VLAN is actually limited by the medium. And CLI, many of us has been used for many years. It's lack of that facilitated coordinations in order to support automations. And everything we have that, even with script tools, is still stick with distributed management and configurations. ACL, which is a firewall technology, which has very coupled connections with the interfaces and the directions, and which is really tied into the devices, can hardly be reused across device. And when ACL grows too big, I believe you all have that experience. From the management perspective and from the troubleshooting perspective and hardware resource perspective, the costs become very, very outstanding. So with so many problems, how could we build an infrastructure to support our applications today, like the way that the Matrix support Agent Smith, so that you imagine our application could be running smoothly, robust, scalable, reliable, and even never die. That is the application-centric infrastructure. I will start with the key components and their responsibilities of the ACI, so that you could have a better understanding how do we use that application policy to drive in the infrastructure, and which we can achieve better productivities. And then I will talk about the very innovative innovations from the creative innovation from the ACI forwarding plane, so that we could resolve many of the known issues from the forwarding or switching perspective we have in the traditional switching. After that, we will talk about the APIs, both from northbound and sourcebound, so that you know the automation capabilities, and we will end it up with questions and answers. And during the whole presentation, we will have a few small quiz. So if any one of you pay attention to our presentation and you catch the keywords, and you will get a small gift here, and if you answer that question correctly. So Dimitri can show a small gift. We selected this small handball is because when I traveled here, my son asked me, "Hey, Dad, can you bring me some gift when you come back from Melbourne?" And I have no idea which kind of thing he would like. So I think probably some of you would have a similar request or requirement. That's why. ACI Fabric, or Application-Centric Infrastructure, consists of one or multiple ACI fabrics, which is driven by the application policies and through a cluster of the controllers, so that we could achieve a declarative intent-based automations and the logic network provisioning of stateless hardware, as well as rapid deployment of the applications onto the networks with scale, security, and full visibilities. And this is a solution we've never seen before. And before we talk about the ACI Fabric, I would like to bring back a little bit for the Matrix. Actually, if you remember in the Matrix, that is Morpheus, and he was saved by the Neo, and he used a phone box and answered that phone call and transitioned from Matrix back to a spaceship. And similarly, in the VXLAN network, VTAP or VXLAN tunnel endpoint is provided similar functionalities, so that the data frame, which is coming from the line segment interface, could traverse through the IP interfaces and over that IP network and reach the far end, but retain that segmentation attributes, which is represented by the VNID or VXLAN network ID. A VXLAN network ID is a 24-bit of the field from the VXLAN header, which support or represent about 16 million of unique IDs. As a result, the limitation of the VLAN, which is for the 4,000 unique IDs, is resolved. And if we could have a global consistent schema or allocation plan for the VXLAN IDs, we can easily extend a VXLAN segment from anywhere to anywhere where the IP is reachable. And Cisco ACI fabric is natively designed based on the VXLAN technology. An ACI fabric, like in the diagram here, consists of 2 ACI span switches and 4 ACI leaf switches. And each ACI leaf switches is a hardware VTAP, which support both IP interface and line segment interface. What we call the line segment interface is where we attach the endpoints, such as the servers, virtual machines, and the printers there. And also that APIC or controller. We will talk that in detail later. And the IP interfaces provide high-speed IP connections to the span switch. That is where we have the span proxy or the endpoint mapping database between the endpoint and the VTAP or what the leaf switch is. So that whenever a leaf switch is unaware where the destination is located or has never learned that before, the traffic would be forwarded to the span for proxy lookup. And span could make the decision either forwarded that if he knows that or if drop that if the endpoint has never seen before. And from this perspective, we actually call the span as the oracle because he knows everything. And we call the leaf switch as the citizen. And both ACI span switches and the leaf switches are running a specific ACI software which is built on the technology we all familiar with. It's not a brand new everything. And so that the knowledge we have from the show command line there can still be reused, but changed to a slightly different mindset from the VRF perspective. And the APIC is where the controller sitting with could support different policies so that when we declare a policy from APIC via GUI, API, or CLI, that policy will be resolved and intercept input and pushed down to the switches accordingly. And we will talk APIC in next few slides. So here we have the quiz. Please, APIC.
Sorry, yeah. If you just go back one slide.
Yeah.
Just as a bit of a question to the room. The top is the spine, the bottoms are the leaves. It kind of, if you think about that, it's a deconstructed switch. The top is the back plane of the switch. It's not the intelligent part. These are the line cards on the front of the switch. So whenever you look at an ACI fabric, treat it like a switch, okay, that you have different line cards. So you can scale by adding more spine, and that scales for throughput, or you can scale the bottom bit is by adding more line cards into your switch. It's very, very simple. It's kind of odd, but in ACI mode, you can get a different availability profile than if you were using a standard chassis-based thing. You can actually achieve a high availability using ACI than you can if you were using chassis-based stuff. But just keep that in the back of your mind, that backplane, line cards.
Thank you, Mitch. So we are having our first quiz. Would you like?
Okay, so first quiz is how many different segmentations, or the amount of segmentation, what do we use to segment up the fabric? We use VXLAN, and how many different VXLANs can we have? It's a large number, 16 million, okay? It beats the 4,000 odd VLANs, we're now at 16 million, so you guys should have enough scalability there.
Thank you for that question and answer. Thank you, Mitch. And we introduced the ACI fabric, but the ACI fabric cannot be configured or managed or even monitored without a controller. So I believe many of you have been used CLI, even including me, start from very beginning to implement the configuration for switch. And from personal perspective, I implemented that configuration of the Catalyst 6K from 2003. That actually gave me a very enjoyable moment because I feel that I have commanded rocket science and I will have a bright future. And that did work because after that, a few months later, I got a new job with double pay because I can configure Catalyst 6K. And after that, in another project, I had to implement the basic connectivities for 30 switches and within 8 hours because the project timeline was very, very tight. And what I did that day was actually create a template and repeat that similar tasks for 30 times and go into different floors and different switches. That's not bad, and I'll call that as a big success because I was able to do that. And for the rest of configurations, such as syslogs, AAA, or SNMPs, which are same across devices, and a template can, or the scripting tools like Ansible we use today, can easily be leveraged and make that automation happen. However, for those things like routing protocols, routing policies, access control lists, which are very much topology dependent, and I really had to configure them manually and one by one. And sometimes I'm really concerned that am I really used the correct command line to enable a feature sufficiently. And after several similar projects, and I figured out configure switch from CLI is just one of the many IT management tasks like you guys have been doing every day. And I believe everyone can even do better than me. So nowadays, when I recall that, those many efforts in times we spent against the solution we have today for ACI, I really wish my customer at that point in time would have ACI. Because building an ACI fabric, which is very, very straightforward, which means we do not have to configure anything from the console port for any switches. And the whole fabric is discovered and built with zero-touch deployment. That's what we call it. And no matter how many switches or APIC you have. And what we need is to just configure the ACI APIC while set up script, and then link layer discovery protocol will kick in and discover the topology automatically. And a DHCP or dynamic host control protocol will be in charge of IP address allocations. And as soon as the switch is registered, you can register that from GUI, from CLI, or from the APIs. As a result, we can bring up a fabric with 30 if switches within 15 minutes, just 15 minutes. And that is the thing I have spent for the whole day to do back to the old days. And furthermore, because everything in the ACI fabric is not like a show running configuration with save into the environment, is actually represented by object models. What does that mean? Which means everything is like switches, interface, the interface parameters, hardware resources like TCAM, and topology informations, and the configuration at the topology dependency, relationships between objects, and all of them are represented by the object and organized by the management information tree, such as tenant, you see the tree here. So when one object is created, the other object which is dependent on that would be created automatically. With the intelligence of the APIC, those things we have to manually apply configure, like create VLANs and allow VLAN onto a trunk port, and then create SVIs or send IP addresses, install static routes, enable OSPF, EIGRP, everything, and then enable BGPs, create route reflectors, and create roadmaps, create IP prefix list. And everything is all coordinated by the APIC. And based on the topology dependency, we do not have to do anything. And thirdly, when a logical error or deployment error happen, faults will be raised, and the controller knows that, and will become visible from the GUI so that we can correct them. Many of us had to facilitate the networks as if we were a network controller. And now with ACI, we are all liberated from those tasks, liberated from the CLI and the distributor approach. And with ACI, we are shifting to a new chapter that we can provisioning and manage and monitor ACI fabric through graphical interfaces, APIs, as well as policy models. So another quiz time.
What does APIC stand for? See, that's one thing, one acronym you have to learn. Application Policy Infrastructure Controller. It's a mouthful. We won't repeat it again. It'll just be APIC, okay? Let's give the guy.
So you're going to through that.
Yes.
Thank you. So we talk about the controllers. So how does the policy model looks like?
Just a question for that.
Yeah, please.
So the API interface from administrator side is probably Distributor, right? What is the, is it SSH or Telnet that it uses on the back end to talk to the switches? Or do you sort of respond with?
So the backend we talk between the APIC and the switches, which is what we call the UpFlex protocols or policy protocols. It's different than SSH. So we use the policy models. We are going to talk that in detail later. Yeah. Does that answer your question?
Just a question on that. Is that encrypted or is that secure text?
Yes, definitely it's encrypted by SSL. Yeah. Yeah. Thank you. So we talk about controllers, and so how does the policy model looks like? See, in policy models from the application world, which we talk about that, about the application tiers and dependence, security requirement. So that when a policy is declared and with APIC or the controller, which can understand the policy and which is capable of resolve the policies into different languages, like network languages, VRFs, and so on and so forth, computer languages, as well as security languages. And the ACI policies can be subdivided into two main categories. One is access policies, which determines the interface level or infrastructure level settings, define how the interface is configured and used, especially for the interface parameters. And the tenant policies is where we define that traditional networks, and that is where the logical connectivity is defined. And they work together in tandem to define how and where endpoints and applications are connected. From the detail perspective, access policy include interface policies, which include a bunch of interface settings, and everything comes with default settings. We do not have to touch anything until there is a specific reasons. And the interface policies are grouped together by the interface policy group, and then tied to the interface selectors or interface IDs. That's what we call interface profile. Interface policy group will also consume that global resources, which is like VLAN pools. Every VLAN pool is mapping a unique region of VXLAN pool as well, implicitly. And then, which will be consumed by the different type of domains, such as physical domains, which is where the bare metal server connected, or VMN domains, which is the virtual machine integration happen. And then the domains are associated, or multi-domains can be associated to attachable entity profile. One AEP could be associated to multiple domains. And the AEP is consumed by that interface policy group. As a result, we are telling that which interfaces and with which parameters can use a certain amount of resources.
So another way of looking at it, and put up your hand if you've ever deployed an access point. Some of you guys, okay? So access points, there are a lot of them in a big organization. You go into the central world and you just get this right once, okay? What we actually find is talking to our clients, like yourselves, that they learn this, they put this in their head, and then they set it up one time, and then they just keep on deploying, and then they forget what they've actually done because this is only a once-off type thing, okay? So it might seem complex, but when you work through it, think about this. This is like defining what your switch ports do, what your switches do before you actually have the switches arrive. You get all the maths done right, you sit down, and then when you deploy it, it's just like deploying an access point. You put it on, you click it, and you say, add to my network, add to my network, add to my network. That's what this is about. Getting your policy right. It is convoluted, but there's an easy way of doing it.
Thank you, Mitch. And the interface profile plus the interface switch IDs is together what we call a switch profile. And that is under the category of switch policies. So in summary, switch policies, global policies, as well as interface policies. With the diagram here, we are able to implement 100 switches, each with 48 ports, and allows them to consume a certain range of VLANs or VXLANs, and with the default level settings. And this is a template we can create once and reuse multiple times. As a result, we can implement that basic connectivities for 100 switches within just 5 minutes. So think of that. If you have 30 switches before, we spend the whole day, and then now we just use 5 minutes. That's the power of that. And tenant policies is where we define that onboarding our customers, business unit, and customers into the ACI shared infrastructures. Each tenant is equivalent like a VDC concept in Nexus operating system. By the way, there are a few seats from the front. If the guy sitting stand there, please welcome to the front. Thank you. And each tenant could include multiple or single VRFs, which is where our layer 3 domains. And each VRF will contain one or multiple bridge domains, which is where the broadcast domain subnet as well as we are sitting with. And within bridge domains, we can have multiple endpoint groups, which is where the endpoint attached with, such as bare metal servers, virtual machines, and storage, and so on and so forth. And the EPG can be classified based on different type of attributes, such as VLANs, IP address, MAC address, operating system type, virtual machine attributes, which is about micro-segmentation. We will talk later in detail. So when the endpoint groups are grouped together, we actually created them based on the application purpose, such as I have group of servers which provide web services. We call them web EPG. And then so on and so forth for the database group EPG and APP EPGs. The communication between them is in charge by the concept what we call the contract. So in the real world, the contract is something signed between two parties who is providing something and the other is consuming something. And similarly, in the ACI world, the contract is allowing the communication between a group of web servers who provide web services to the group of clients who consume that. You can see the error there. So the contract in other words, we call them as a stateless firewall, which contains one or multiple subjects, is where the application defined. Could be web application, could be database, and so on and so forth. And within the subject, we define the filters, which is where the protocols we want to allow or disallow bad action, either permit or deny. At the end, based on different scopes, like application scope, VRF, tenant, or even global scope, we are able to manipulate that EPG-based ACL plus the routing coordinations. What does that mean, routing coordinations? Which means if you have one BD deployed from one leaf, and that is consumed by another EPG sitting from another leaf, and the static routes will kick in and install from both sides so that they know how to talk to each other. So all of those coordinations and facilities happen natively and naturally by the ACI. You just declare your policies.
Yeah, so back to the analogy of treating your data center like one big switch, okay? Forget about what the 10 looks like. It's one big switch, just tick box, okay? Now I'm developing a policy, which in the old world, it would be one VLAN talking to another VLAN. Between those VLANs, how do we put ACLs or anything? It's hard. We either have to chuck it through a firewall or have to do some manipulation on the switch. Think about if you've got lots of switches, that means a lot of configuration. What we're trying to divorce, you guys are thinking, is that it's one big switch inside the data center, it's ACI. You then apply a policy and you define your groups, EPGs, and inside those EPGs, you allow what traffic you want to talk. It's a whitelist model. Without that contract, nothing talks. You have to enable it, even if it's allow all. Or you can just say, hey, guess what? I only want to do port 22 or 23. You build it from the ground up. Forget about where it is in your data center because that policy is rendered wherever it's needed on every switch. One switch or 100 switches, it'll do the same thing. Okay?
Thank you, Mitch. So in order to migrate or adopt ACI, there are two approaches. One is network-centric, and the other is application-centric. The network-centric is simply we can migrate the legacy VLANs we have and create a one-to-one mapping between the VLANs, endpoint groups, and VLAN and the bridge domains, so that we do not have to modify anything and retain the existing designs, very smoothly migration. And then in parallel, we can embrace and enjoy the next generation of ACI fabric with 100 gigabit data centers, and then optimize the span leaf architecture for the east-west workload and mobility and a program fabric with real-time monitoring and health scores, automation, everything.
Sorry, just a question. So what is the difference between EPG versus bridge domain? Because you're basically using the same VLAN in both, right? So there must be a difference.
Yeah, EPG, like I mentioned before, is where the endpoint attached with, and the bridge domain is where the broadcast domain is synced with. So one EPG can associate with one bridge domain. Yeah, please.
So it's kind of, we're starting to get into some non-technical, non-network centric type stuff. Okay, so before, if you think about it, you have one subnet in your organization just on a switch. Your bridge domain is where the gateway is and down, okay, the layer 2. Well, ACI gives you the ability of having two subnets and a single bridge domain looking after that. So bridge domain is its broadcast domain. Where do you want your broadcast unknown to stretch to? Okay, we tend to have a 1:1 mapping where an EPG has its own bridge domain, but there are some specific use cases where you might want to break that, like for server load balancers or things like that. So we tend to see them as traveling partners, but again, we've seen through various versions of ACI right up into the new one where we give you a tick box to change where the bridge domain is at a drop of a hat. So you can literally say an EPG is a bridge domain, or you define another bridge domain. So that you use them slightly differently.
Does that answer your question? Yeah, thank you. And in order to talk the external or traditional network, we use layer 2 out and layer 3 out. We will talk that in detail later. And in comparison, application-centric configurations allow us to use the same bridge domain and single subnet and create that EPGs based on application purpose instead of VLAN mappings. So the application which is hosting like web services will be grouped together for web EPG, and the virtual machines or other hosted for the applications would be put into the APP EPG, and so on for the database EPGs. And the communication between the EPGs will be precisely controlled based on contract.
So let's have a look at what you do today. When an application groups come to you and say, I have a 3-tier app, the obligatory 3-tier app. You normally say, okay, well, I'm going to give you a VLAN for your web and a VLAN for your app and a VLAN for your database. Okay, so we're literally sort of getting down to the point where ACI can map a VLAN. ACI and EPG in this context equals a VLAN. Okay, that's why we call this network centric. We're doing what we used to do, but just using different names.
Yep, thanks for that. Because we have a contract, we can precisely allow the configuration communication between the EPG. Now in the network-centric mode, we just allow them by default and any to any. And then more importantly, when we scale out the applications, we can easily insert the load balancers, the firewalls, or IPS between the EPGs while service graph. We will talk in detail later, so that the application performances and securities could be accelerated even faster and even better. So that's the benefit or the advantage which is unique for the application-centric mode. So both of them works, and there are different use cases. Like Mitch mentioned, from the network-centric perspective, that is help us to migrate to ACI while retaining the existing designs. And for the application purpose, application-centric mode applies to many of the greenfield build fabrics. And in order to extend to the external world, we use the concept called layer 2 or layer 3 out, which is go out to the fabric. So the layer 3 out, which is a concept that or feature enables routing protocols onto specific interfaces of the border leaf switch, where the external routes is attached. Then we can exchange the routing information between the ACI fabric and external routing domains. And similarly, a layer 2 out enables L2.1Q trunk on specific interfaces of the border leaf where the external switch is connected with, which allows the traffic to be bridged between internal VLANs and external VLANs. When a leaf is added additional row for L2 or L3 out, we call them from the row perspective as border leaf.
So think about it. That's one big switch. I keep on saying one big switch. When you have a switch connected to layer 2, it's simple. It's a trunk port or an access port. Okay? So the leaves have trunk ports or access ports. When you want to peer it with some other thing, layer 3, what do? You run a routing protocol on it. So that one big switch, we turn on a button that says enable BGP or EIGRP or something. Okay? So what we're sort of alluding to is that one big switch can do both layer 2 and layer 3 at the same time. You can have it both or one. You can have network centric, so all of your network, if you've got an existing data center that has 10 VLANs, you can stretch those VLANs into ACI as layer 2, or you can actually have some layer 3 inside it.
So if you want to stretch a layer 2 across to another data center, you would still connect leaf switches across the two sides, or and via, for example, OTV equivalent mechanism?
Correct. So again, good network design is if you've got OTV. So we've had some clients sort of come to us and say, we've got an existing data center. How do we get to here? Okay. One of the migration methods is take one of your sides and turn that into ACI, and have OTV in the middle. So you're talking traditional Nexus over OTV to ACI. That's valid. For some of the newer, and there'll be heaps of information in the next couple of days about ACI multi-site and ACI multi-pod. That's like saying, hey, I've got ACI at both sides, and I have a single policy network. So it's like saying I have an APIC stretched across sites, okay? So there's lots of different use cases. There's no wrong or right answer, it's what's right for you. So we can mix and match it. But essentially, that's what we're saying.
Thank you, Mitch. So layer 2 out can be deployed from a dedicated layer 2 out EPG, like the diagram here, so that we can specify which leaf and which port to allow which particular trunk, VLANs to trunk to the external switches. And a contract can be provided by the layer 2 out EPG, consumed by the bridge domain EPGs. And the other way to do that is we can specify a statical path or port from the EPG perspective to allow that similar VLANs. The benefit of doing that is much more easier and can support multiple VLANs to be activated at the same time. And layer 3 out is where we specify which leaf switch, like a 102 here, interface 1/8, and which is running with the routed sub-interface or SVI, going to the external network and with the IP address, and which allows the external subnet. As a result, if we provided a contract by the layer 3 out and consumed by the application EPGs, the internal BD subnet would be advertised to the external routers, and the external subnet would also be learned from internal. And BGP route reflectors would handle that route propagations between that board leaf switch and the computer leaf switch. If the L3 router is providing a shared access for other VIFs, we call that as a shared L3 route, which means I'm providing some access which can be shared by other or consumed by other VIFs. So similarly, we use contract, which is a big scope, like a global scope, and then that can happen. So we are going to talk about forwarding here. So I believe many of us have embraced the problems like spanning tree loops, right? HSRP split brains, or like unicast flooding has blown out the whole series, or even more like ARP storms, which has consumed a lot of batteries, which are very common and many issues we have seen from a tech perspective and from many customers. And if any of you have seen those issues before, I would like to let you know that we have a better option with ACI. So firstly, with ACI, we do not use spanning tree anymore. So you do not have to worry about anything like spanning tree loops. It's all gone. And then we are going to talk more details from other innovations from a forwarding perspective. So which is similar like a traditional network. Forwarding happens either from layer 3 and layer 2. What we call IP forwarding is basically happen from two endpoints belong to different subnets or different bridge domains, which is very broadcast domain interface. That is, in that situation, traffic coming into the most left leaf switch will have the destination MAC of the bridge domains SVI IP address and the gateway, SVI gateway. So that the lookup, the ingress leaf would treat that as an IP forwarding packet and look up into the VF by the destination IP address. And from a hardware perspective, we would also learn source IP and the MAC address and use that learning and publish to the span so that span knows where the endpoint and the VTAP is. And for the future, the span can use that information for proxy purpose. And the MAC forwarding happened between two endpoints belonging to the same subnet and or bridge domains, even same EPGs. And destination MAC must be another endpoint. Therefore, the lookup domain happened from the bridge domain perspective, and then the hardware learning happened from source MAC only. And similarly, we will publish the local learnings and to the span, so the Oracle would know everything from the fabric. And the HSP split bridge, we have to see many of that issues, and we go to very high escalation for this kind of problems. And nowadays with ACI, we do not use HSP anymore. We do not use VRP either. And the proactive gateway features allow us to deploy the subnet and gateway as well as the same MAC address anywhere, anytime when the EPG is deployed. And similarly, the upstorm, which come into a network, which could hit a lot of bottlenecks and bring the whole network down. And we use a very intelligent way to do a layer 3 lookup from the ingress leaf switch based on the learning we have happened before, which is saved into the local or the remote. We talked that in detail. As a result, the up broadcast would be forwarded very intelligently to the egress leaf switch where the endpoint is attached, as if it was a unicast. So that's what we call up unicast. As a result, we will not see any flooding from the up broadcast into the ACI fabric. The bandwidth is highly and efficiently used. Host routing is where we route that IPv4 or IPv6 packets. So from the ingress leaf switch, which is sitting from the far left end, we are going to learn the source. I'm sorry, does that mic still work? Yes, still switch on. Yeah.
Just check the battery.
Yeah. Yep. I think I run out of. I think that one.
Oh, you're going to swap?
Yeah.
Okay, cool.
Yeah. Thank you. Sorry about that. Probably I rehearsed too much time, so I ran out of battery. I had a rehearsal this morning. Thank you. So from the ingress leaf perspective, we are going to learn the source IP and source MAC based on the IP forwarding or MAC forwarding and save a local cache for 15 minutes. So for next time, we do not learn that anymore. And that learning would be published to the span for proxy and lookup. And for the conversations between the locally endpoint and the remote endpoint, we would also catch that remote endpoint information as well as the VTAP, where the leaf sitting is. As a result, we can use the conversation learning and expedite the forwarding decisions, which is more and more efficient. And if the destination is unknown or which match anything which haven't seen before, you see the star here. So the proxy will be used. The proxy functionality is handled by span, and span is able to save up around 1 million of the endpoint so that we can scale out the ACI fabric up to 1 million of the host. That is the biggest fabric I have ever seen in the industry. Yep.
Is it a single proxy across the fabric, or
Is it a single fabric across the fabric?
Both of them would acting as a proxy. Because the traffic is hashed to the span based on the hash algorithm, both proxy or both spans share the identical database, so they talk to each other. So anytime when the packet comes into either of the proxy, and they would handle them similarly with the same result. Yeah, very good question. Thank you. Yep.
If you kind of look at what's happening, if a device is unknown on a switch and the switch itself doesn't have the MAC address, it refers to the proxy, any one of those. So there's multiple leaves or multiple links to multiple proxies. It'll just ask one of them. All of them hold the same database. And because no one switch holds all of the MAC addresses, it means we can scale to 1 million MAC addresses across the whole switch.
Yep.
When I say the switch, it's the data center.
Thank you. Mike, can I have a ball for that gentleman? Thank you for that. Otherwise, I would not talk to this. Yep. Yeah, for the external subnet routings, which is where we use the external subnet sitting behind our throughout. This forwarding is very straight away because the ingress leaf switch sitting from far end knows where the destination subnet is. So we are not going to involve proxy, but use forward that packet as IP packet by the proxy perspective and go to the egress leaf straight away. And the forwarding lookup would continue from there. In summary, the forwarding scope from ACI fabric could vary based on different situations. If two endpoints belong to EPG1, we are going to use MAC forwarding, and there is no contract required by default. And if the endpoint A wanted to talk to endpoint C, which belong to different EPGs but same bridge domain, and MAC forwarding plus contract is required because we want to enforce the security. And the endpoint A would like to talk to the endpoint D, which is belong to the same bridge domain but different subnet. So we are going to use IP forwarding, and the contract is required. And for endpoint A, talk to endpoint E, which is belong to different bridge domain and different subnet. IP forwarding is definitely required, and the contract must allow that. If the endpoint A talk to endpoint E, which belong to a different VRF, we are going to need that inter-VRF leaking, and based on IP forwarding, and the contract is also required. And in all the situations, you do not have to install any static route, dynamic route, and contract would coordinate all those communications. So what we need is just provided the services and consume that. Epic as a controller would consolidate, coordinate, and facilitate everything for you. So that's what is the benefit or the beauty of the controller.
So the inter-VRF leaking is in the contract or the way we define the inter-VRF leaking?
Yeah, so thank you for that. The question is how the inter-VRF leaking can be configured, if I get that correctly. So inter-VRF leaking happened when I provided a contract by a subnet from one EPG and consumed by another subnet from another bridge domain or EPG. So consumed by basically happen between EPGs. Therefore, the inter-VRF leaking will kick in automatically, intelligently, based on your purpose or intent. So that is what we call intent-based automation. Yep.
We can also show you where in the configuration it is later. Okay, a lot of this stuff it's hard. We're miming up here, saying it's very, very easy to look, but there's the other part of it is going inside the APIC and finding out where that is. Okay, so we can certainly, there's enough gentlemen in the room here that we can certainly point that out. The other thing that I just want to also, this shows, I guess, a progression of what we need in network. We've never related to how that relates to the whole data center. Okay, you don't get to choose, you don't have to choose where your gateways are, because all your gateways are all taken care of because of the policy. The policy will render itself across all network elements to provide this. So you just define it in the policy, and it doesn't matter if you've got 100 leaf switches or 1 or 2 leaf switches, it just works.
Just a quick question. In the previous slide, you got this multi-tiering approach in your bridge domain, where you have firewalling or perhaps some type of protection. Is that a container within the fabric, these firewalls, or is?
Container, it's within it, again, underneath the hood, it's VXLAN. So it's in its own VXLAN. Okay, so is that a container? No, it's an encapsulation. It is Coke and Pepsi side by side. Okay, it is the ability to kind of say, okay, so I guess from my own experience, I worked with the TAC guys the other day for a client of mine, and they gave me a tenant, and all I could see was a tenant called the client's name and another tenant called common where there was a firewall. There's another 30 odd tenants in there that I couldn't see, couldn't do, couldn't affect. Okay, so it is a purpose-built multi-tenancy that every tenant can have this in there, and Coke and Pepsi never mix. Okay.
Yep, this slide, thank you for that question. This slide is a high-level packet walk. I'm not going to go into details. So for any of you who are interested with that, download the slides and have a look. And we have Spectrum available, and we can address any concerns you have. And another quiz time.
I've got to work out the question, sorry. Damn, I'm the most important. Okay.
Yeah, go ahead.
Go for it. You can ask a question.
Okay, sorry. The question is, what innovations does ACI use to resolve ARP broadcast storm?
It's a hard question, but we'll accept close to it.
What innovations does ACI use to resolve the ARP broadcast storm? Because ARP is flooded everywhere, right? So, yep. Awesome.
Unicast.
ARP Unicast. Yeah. Thank you for that. Then security definitely is always a top priority for many customers. And in ACI world, we're not doing the way like we have been doing for the traditional switch, which is what we call the trust based on locations. So by default, the server 2 and the 3 can talk to each other until there's a blacklist happen. In ACI, we use zero trust models. Zero trust, which means we do not allow everything until there's an explicit contract allows them. Like the diagram here, server 2 cannot talk to server 3 until we have contract. And furthermore, ACI delivers that hypervisor agnostic microsegmentations, which allows us to segment the EPGs further and more precisely and to define the security policies. So we use to define the EPG based on a group policy purpose, and then we can even split that in different small slices, such as based on the IP addresses, operating system type, or even virtual machine name. That happen, and that is also supported. And based on some hardware require additional, some features require additional hardwares. And for the intra-EPG based isolations, which we can also disable that intra-EPG communication so that we can achieve similar like a private VLAN effect. I'll quick finish that and we can have some QA. Yeah, thank you for that. And then last thing, we are going to talk about the more than forwarding or more than switching. We have been talking about the innovations of the switching, packet switching and forwarding. And ACI is not really about only of that. ACI has provided more, so more than switchings. In the glance, we support around 65 of the ecosystem partners. We can provide northbound APIs for programming abilities, and we also can orchestrate many things like hypervisors, layer 4 and 7 devices from a sourcebound perspective. And for example, we use to configure that network or ACI fabric manually to create VLAN and enable that in order to talk to the virtual machines, which is sitting from the hypervisors. And that task is very manually. So like the steps here, you see at least 5 or 6 different steps, all are manual. And with the VMM integration introduced by ACI, when ACI is integrated and interacting with vCenters, everything is automated. So that automation means when we create an endpoint group or EPG from ACI perspective, the relevant VLANs which are allocated for the VMM domain would be dynamically picked up and pushed down to the leaf switch and trunked over there towards the virtual machine or the EXI where we connect with, which can be detected by LDP protocols. And therefore, we can also push down that port groups with specific VLANs we allocated for switch, so we have a consistent VLAN allocations. At the end, we do not have to touch anything from the VMware perspective. The only required is we attach the virtual machines to that port group. With that, we can orchestrate the hypervisors, please.
So if I was to ask for a show of hands in here, who's a network engineer that looks after the virtual access layer? So the VMware or the Hyper-V hypervisor switch? Is that, see, and this is the odd thing is it's a piece of networking equipment, but we kind of say server team does it, okay? So what we're talking about here is the integration in saying, when we go VLAN equals EPG or EPG equals web app, why can't we just push it down to the virtual layer and get it to create the port profile with all of the right configuration in? So inside ACI, there is a layer 4 to 7 integrations. You can literally say, this is my vCenter. It can do, I think at last count, like 40 plus vCenters or something like that. It's an incredibly big number. So you can say, create this EPG, and it will go to the appropriate vCenter and make a port profile. So if you do want to get a chance to actually have a look at that, go down to the DevNet stand downstairs and play around with one of the pods, because they have the automation software. You can say deploy 10 VMs and it will instantly construct the distributed virtual switch. It will add the VM to the port profile, and then when you click delete, it removes itself and cleans itself up. But this is the idea about automation. Think about inside your data center. With large data centers, do we ever tell the server people, no, you have to install all your servers in racks 2 and 3, because that's where I've set up the configuration. So being that ACI is a switch that extends across your whole data center, you can say, look, literally plug them in wherever, and we'll configure them wherever, because it's one big switch. Just because you could doesn't mean you should. There's still good design in putting things in the right location and stuff, but it's less important. But you can certainly say to the VMware people and the Hyper-V people, we will deliver it right to the front door so your VM can have just the port profile or the networking stuff that you like, okay?
Yeah, thanks for that. Really appreciate it. Yeah, please.
But then what happens if you say, for example, because we have this situation where one VM moves from this place to another place, and in post-base configuration, you've given the VLANs out, and the VLANs have to move. Can that all be taken care of?
It's all taken care of. Okay, so consider that is you've put the VLAN or EPG into your fabric. It exists across the whole data center, that if you're on the left-hand 2 switches and you move them right to the right-hand 2 switches, doesn't matter, it's still there, okay?
Before you said about multi-tenancy. So if I'm in one tenant and basically I'm looking at one virtual system here,
Yep.
then I move that same virtual system into another multi-tenancy. Will that VLAN be stretched across that multi-tenancy?
I think I need to understand a little bit more. So when you say multi-tenancy, you're moving into another data center? Or, okay, so that's where I guess we've come up with the idea that we've got this new reference architecture called multi-site or multi-pod, okay? So if you're using multi-pod, yes, just consider it one logical data center geographically separated over 2 sites, because there is a series of APICs that stretch across both. So when you build EPG red, it exists in both sides at the same time. So you can vMotion it to the other side, assuming you can get it there. Doesn't matter, it's one big switch, it's just connected over the other side. So there are lots of different things. So I can't say yes, but we can certainly whiteboard it and I can talk you through it.
Yeah, we have a meet expert board session this afternoon at 5:30. Anyone have any questions, feel free to reach out to us there. So same thing applies to the Microsoft integration as well. A part of the, we will do that quiz at the bottom. So a part of that orchestration for the hypervisors, we can also orchestrate a layer 4 and 7 devices, so that we can extend the policy models to the firewalls, load balancers, and so on and so forth. And the service graph is we can apply based on contract. So with the service graph sitting between the EPGs, we are able to redirect or manipulate the packet flows between that source and destination into the firewalls, load balancers, and achieve better performance and security. As a result, we can achieve network automation as well as layer 4 and 7 automations. Some of the customers would like to use retain the configuration from the service graph, like a load balancer, layer 4, 7 devices. That's the unmanaged mode kicked in. Because with the service graph integration, all the configuration is driven by ACI Fabric through the device package from the APIs. And then for those guys, they wanted to retain the configurations by different teams, they can still do that by unmanaged mode. From the troubleshooting perspective, the visibility and automation tools give us a lot of flexibilities, such as from the APIC GUI, we can run a diagnostic between the endpoints. So what we got is a topology print out, and then we know where the endpoint is attached. If there is faults and the packet drop, the contract is that okay, and so on and so forth. And from the automation perspective, we also have many applications which can be installed or self-developed and put into the APIC. That is their APP center. You are welcome to visit and download from there. And to wrap it up, we started with the distributed and siloed mode. So we are having a problem from legacy infrastructures. That's why we use ACI in a centralized way and use that policy-driven model so that we can deploy applications like the way we support matrix support agencies so that the application can be ready within minutes. VLAN segmentation limitation is gone because we have VX lines. And the workload can be deployed anywhere, anytime, because the innovative forwarding planes we have from ACI. CLI is not a big concern anymore because we have northbound and southbound applications, APIs, and orchestrations. ACL is replaced by the contract, and with together like microsegmentations. That's the result. We are very confident to see that ACI could be the matrix for your applications if we really consider that. And if any of you have deployed ACI in your organization or plan to do that, do not worry about the support perspective. This bunch of people with 13 team members are in our team, and at least 11 of them us hold at least one CCIE. And we are leading by a most smart guy called Eugene here. And we are very deeply understanding in ACI, the DCN, and security, as well as server virtualizations. Furthermore, we have the best support from engineering perspective, ISBU. So this is just one example. A bunch of senior person, like directors, like VPs, they work together over from the day till the 3 a.m. morning. They wanted to excel the ACI or solution into the next chapter in order to support the big scale and better customer impact. As a result, or from our perspective, the best SDN solution, the best way to learn is definitely teaching. I do not know anything from a sales perspective. Mitch helped me, and we can talk about some market things. And then the best SDN solution is for ACI, and we all believe that. And from the engineering perspective, we know ISBU is providing best support so that you do not worry about that. That's what we have all for today. And thank you all for coming. Thank you.